If you try to always have the best of the best, you're never going to have anything. Everything starts bad and gets improved over time and as needed. So I've never been advocating for having the perfect event right away with all the information that you need. So you need to start somewhere. And then eventually it will get to a point where it's recognized as reliable information for everyone and of good enough quality for people to be able to rely on it.
Welcome to Nerd Out at Spotify, where we bring you behind the curtain of the world's most popular audio streaming subscription service. Machine learning, open source, clouds, tabs versus spaces. We'll talk to Spotify engineers about interesting tech issues, big and small. I'm Dave Zolotuski, principal engineer at Spotify. Today, we're talking about event delivery. When you do something like tap the play button in the Spotify app, that's an event. And getting that event data is fundamental to the Spotify experience. Without it, we wouldn't be able to make music recommendations, pay artists fairly, or track down pesky, hard-to-find bugs. At the most basic level, this seems like a straightforward process. Just record an event, send that data to a server somewhere, and do something useful with it. It's easy, right? But now, multiply that process by 50 million events per second. It's a lot to handle. So how do we make sure all that important data is delivered reliably from our clients to the cloud? And once that data gets to where it needs to go, how do we make sure our engineers can make sense of all of it, let alone do something useful with it? Well, it's been a journey. And it's a story about scale, as much as it is about the ins and outs of moving data through pipes using Apache Kafka and Google PubSub. To talk about that journey, I'm joined by Spotify staff engineer Ricardo Petrocco. From pragmatic steps to big transformations, he's seen how event delivery has evolved at Spotify over the years and where we're headed next. Hey, Ricardo, it's great to have you on. Can you just introduce yourself and tell us a little bit about what you do at Spotify?
Hi, I'm Ricardo Petrocco. I've been an engineer at Spotify for the past 9+ years. And mostly been in the space of data or the space in between data, backend, and everything that lies in between.
So let's start with the 9 years part. That's a long time. Tell me about some of the things you've done over those years. And then I want you to explain that last thing you said.
Sure. It was an interesting journey. I came to Spotify, it was 2014, to try to solve a problem that I had at the time, which was trying to find a way to scale up the collection of data from the clients. And we were moving from a model where we were collecting data using SAP. And then basically they figured out, okay, that's not scaling anymore. And they're trying to find a better way of doing it. And this was in the very early days of Kafka, just to put things into perspective for people that know about it. And it's a way of collecting data from a source and put them in a destination, usually a storage solution. And for me, what was appealing at the time was that Spotify was in the edge between having to find a pragmatic solution and having to scale it up. So when you're a small company, you usually try to find a quick and dirty solution that just works. And as you grow, you have to scale it out, make it more complex. And I think that was the space where I started.
I gotcha. That sounds like an awesome journey. So I think we'll have plenty of stuff to cover. But let's start with, you said collection of data from clients. Like what sort of data? And in this context, what are clients?
Clients at Spotify is everything that is able to reproduce a stream, which might be originally an audio stream and now could be a video stream or others. And those go from a mobile, like a mobile phone, your iPhone, to your computer, to your car, to your fridge, to an independent speaker, to whatever it is. And it started by being able to collect just the data that we need to pay our royalties. And then it moved into trying to determine what music the users like and what to recommend next and how to improve the product and understand which of our features are actually being used by our users or which ones are too hard to get to.
I gotcha. So it's kind of everything from what people are listening to, more like product feedback for our teams to know what to build or what to stop building.
I mean, by now it's a huge amount of data we collect, and it's basically the differentiating factor of Spotify in one way. It's not only a place where you can get music and stream it, but it's also a place that tries to give you the right music. And apparently trying to get you the right music is the hard part, and that's why we keep on getting a lot of data.
And I guess we're pretty good at it because people keep coming back for it.
I think we have done a pretty good job in making that process straightforward enough.
Yeah. No, that's great. I want to dig into a lot of the systems you work through because I'm assuming from 2014 to now, a lot of these things have changed. I think now we call it event delivery, but you said it sounded more like we called it data collection at the time. What did the system look like when you joined in 2014?
Originally, and to be fair, for part of our infrastructure is still the case, we used to collect all the data coming from the clients on our backend systems or backend servers at the time. And then from there, we'll just dump it in a syslog file. Like we send strings from the client and we just save them on disk. And then we had a small process running on the servers that would just read whatever is on that file and send it over. And originally was done with purely SCP, like take the file and dump them into our HDFS cluster or Hadoop cluster in London, physical cluster. And after that, that wasn't scaling anymore. So before me, it was the times of Kafka 0.6, I think, or 0.5, so early times. And the brilliant people that were there before I joined, basically they implemented an entire system that was using the data, relying on Kafka, but the difference was that we are doing it cross-continent, and Kafka wasn't designed for it. And since we needed to have a reliable delivery, like completeness was the key part, all of a sudden we had a system that was able to deliver the data to HDFS cluster, but then we needed a pingback. So we had like another path for the data to send back an acknowledgement to the original daemon running on each server, reading the data to actually acknowledge that the data was received. So we ended up with this double chain where every Kafka consumer was also a producer of data, and it wasn't built for scaling at that level. So I remember when we talked with the engineers that actually built Kafka and we told them what we were doing, they were like, "You're doing what?"
Maybe don't.
Maybe don't. Yeah, exactly. That was not necessarily the use case for them.
I gotcha. So I guess it sounds like you joined not even with the first system that did this, not so much at the kind of SCP level, but you joined when it was more already on Kafka, but Kafka wasn't scaling to what we were doing with it.
Exactly. We had constant incidents. It was a time where we are handling on-prem, where we had our own network connections, where we are partially going through the wild internet, where there were problems with actual physical servers. And we were the only system that was touching on all of those constantly with an enormous load for that time. Now we are several order of magnitude more, but we were basically catching everything that was going wrong in this type of infrastructures, which was an interesting time.
Yes. Were there any particularly fun incidents that you can look back on fondly now?
I remember Mark in one of the previous episodes mentioned the Summer of Incident. That was a fun one. I worked 24/7 for 3 weeks in a row. Not obligated. No one needs to be scared here. It's like it was voluntarily, but we could just not get the data through. So there were a couple of problems. One was that we're running out of capacity in our Hadoop cluster, so we're constantly firefighting there. But then the other thing is like for some reason, the throughput of our event delivery was simply not working. And then spoiler alert, it turns out that one of the major reasons was that in one of our physical data centers, there was a wrong kernel released to some of the machines that had a bug that thought it was overheating. So what will happen is that just a minority of the machines would actually throttle down because they thought that they were thermal throttling. But then if they were assigned to be a broker, basically everyone will adapt to the performance of the lowest machine, which means that all of a sudden the entire broker's cluster will go down or will slow down and we could not get throughput. But then we are reprovision machines and then all of a sudden it was fine. And then like a day later, everything was bad again. And until we figured out that it was actually a kernel bug, it took some doing. But those were the type of incidents that we are facing.
Yeah, just reprovision everything once a day.
Basically, yes. I think at a certain point, we even had the script doing it. I think we even had the script that after a certain amount of time, would just kill the machine and reprovision it.
Nice. Is broker a Kafka concept?
Yeah, sorry. Kafka as a delivery platform has several components in the line, and there were like brokers where a cluster were responsible of replicating data and making sure that it was delivered, like of an intermediate. And there was also another type of component that gave us a lot of nightmares, which were the zookeepers and all of this. So it's like there were many components in the pipe that I'm not going to go into details, but that might have been affecting one way or the other. But the simple reality is at that time, Kafka was built in a way that it was working pretty well if all the resources were collocated. And that was the purpose for LinkedIn. If you were scrolling through your feed at that time, you will quite often get duplicates in the feed or they were not really reliable, but that was a fully acceptable solution for LinkedIn. If part of your infrastructure is in California and the rest is in London and some is in Stockholm and your data goes through all of those, that's where things starts to get a bit shady.
Just for example, to pick 3 locations out of
yeah,
out
exactly.
of nowhere.
3 locations that we actually had data centers back in the time.
Yes. Yep. So then tell me a little bit about what you did from here. You mentioned that completeness was the most important thing. What were the metrics you were looking at, and what did you do to make this thing scale?
We implemented a bunch of systems around it. So completeness was a key part, but then also the fact that we're saving data on disk and those machines could be brought down at any time and reprovisioned at any time. And we needed to make sure that all the data was out in time. So we had another system running in parallel with those that were actually reading what was on each machine and reporting back. And we'll then check what was delivered on the other end, which we call the big brother, because it's like usual, you don't want to have a system monitoring itself. So it's like introduce another system and just monitors the system. But then you go into the endless loops, like who's monitoring the system is actually monitoring the system. So we had also the little brother that was checking on the big brother. And then we stopped. 3 levels were good enough. But yeah, that system didn't last very long. I think when we started moving to the cloud or moving back to the cloud, I would say, that's when we started considering replacing some of the components. And that's, I think, already by 2015, 16, we started replacing Kafka with PubSub, and we started to replacing different components, our ETL jobs, rethinking the entire system. So I think we were hitting some limitations at that time for the scale that we were operating at, where managing all of the hardware on your own didn't make sense anymore.
Yep. So let me start by picking on the way you said moving back to cloud. We've always told this story of moving from our data centers to cloud. How is it back?
I wasn't there at the time, but it all started with, there is a famous picture of our first HDFS cluster in the offices, which were just 3 machines running in the gaming room. And then we moved to AWS. I wasn't there at the time. I just know that we had a migration there. And then we decided that it wasn't working for us at that time. And then we moved back to heavy on-premise with some caveats. Like I remember we had our staging environment and we could provision machine on AWS and we're still running some things there. But when it came to the bulk of our infrastructure, it was running on-premise again. And then we started to scaling that out until we reached a point where we had the biggest Hadoop cluster in Europe and we could not physically build another data center. We had basically rented out every machine in that data center. It's like, okay, we're running out. We need a new solution. And I think that's when the Google collaboration came along. And they were in the early stages. We were eager to have a partner in crime that would want to fit our needs at that time. And that's when we started thinking about moving back to the cloud.
Yep. So then let's go there. You talked about a bunch of issues we had with the system, scale issues we were hit, and we were moving to cloud at the same time. So it sounds like there were multiple fairly deep architectural changes we were making at the same time.
There were many. It's like the good thing is by going through many iterations of the event delivery system is that you learn from the previous mistakes. So one thing that we used to do when reading the files on disk, for example, on our server machines, was to apply a process that was called filter and split. Actually, it was done on the receiver end. That was the interesting part. So once we receive all the data, we are starting to look at, okay, what did we actually get? And start reading all these log lines. It's like, okay, this one is an event, this one is garbage, this one is an event. And that process was quite time consuming because all of a sudden you're doing cleansing in a post-processing world. And one thing that we realized is that a lot of the things all the garbage we're collecting on one end. And then it turns out that a lot of teams, since instrumenting the event delivery to recognize events as events was extremely complicated at that time, a lot of teams couldn't be bothered. So they would rather have us deliver the data and then go through all the pile of rejected events to actually find their data. And it turns out that, for example, the financial things or other things or debug logs or everything, at a certain point, we almost had more data that we were discarding than the data that we were accepting. So that was one of the changes that we did, is like, okay, rethink how we can do this properly. And honestly, delegating all the transport layer to someone else and not having to take care of all those machines gave us a lot of room to focus on other things, like move a little bit up the stack. So all of a sudden, we had just a simple job that was going and trying to interpret the data. We're sending the data already structured from the source. So it's like on the machines, we're reading the data and already dividing them per topic and dividing them per type of event. Send them on different topics on pops up. And then on the other end, we had our ETL job that just takes the data, extracts it, makes sense of it, deduplicates it, and stores it in hourly buckets. And life became a lot simpler. So it was day and night, basically, between a system where you have to operate every single machine to a system where you have guaranteed delivery at least once, and you're not the one operating it.
Yep. No, that makes sense. Let me back you up a little bit. You talked about filtering and splitting, and you talked about discarding events. Tell me a little bit more about what that process is and why we're even discarding data that we've delivered.
I mean, it goes back from the times before. So we're fetching the data from syslog because that's simply where it used to be saved on the server machines, and everything can go in syslog. So we're saving actual events, which was the communication that we're receiving from the clients, but there was a lot of other things that could be in there. And that was given for granted, or you could not necessarily assume that everything that was in there was actually valuable. So we had a list of definitions of what we consider a valid event. So it needed to have certain properties, it needed to have some identifiers for us to basically kind of glorified regex. And if that line of syslog matched regex, then we knew how to handle it. Like, okay, then we can structure it, we can save it on our storage solution, which before used to be HDFS and then became GCS, but it's like in our format, we have a schema that we can attach to it and everything is good. And then the problem was all the rest that didn't match anything, and we will just dump it on the side. But that was a lot of waste, right? Because we were spending a lot of resources actually moving this data around. So that's when we decided to do the filtering on the source, like move the entire logic right at the source instead of transmitting everything, just transmit what you think it's important.
I gotcha. And you mentioned a whole bunch of like impact from migration to cloud, things like not managing the systems. Was there a lot in the new systems that kind of wasn't even possible in our data centers? Or was it really just a matter of we did these two things at the same time, so we used cloud things?
That's a good question. I think mostly is having the resources to move up the stack. That's the first one. The systems were complicated to manage them when you have to manage everything, and you didn't have the capacity to improve on things. Our filter and split job was enough complicated that we didn't have to care about it. But then once the entire problem of having to manage thousands of machines by actually logging into them to check their logs to see what's going on went away, all of a sudden we could think about a proper ETL job. We start thinking on how do we optimize delivery? How do we ultimately change even the way that we define events? How do we get closer to our actual users? And I think that mostly that we are not able to, we didn't have the capacity to focus on other things. And those are things that don't simply scale up by adding people to it, nor by adding other teams to it. So it's things where you need to simplify the problem to be able to focus on something else.
No, so that makes sense. So it's a little bit less of like, this is completely impossible if we own the metal. It's more that our team needs to be, I don't know, X times bigger if we go all the way down to the metal. No, that makes a lot of sense.
Exactly.
I guess this was what, 2016, 17, 18, like the stretch of time when we were looking at cloud and moving.
Yeah, something like this.
I guess that's 5+ years ago now. What's gone on since then?
Since then, we kept on moving up the stack. One big problem that we had back then is that it was instrumenting the code to send events from the clients or collecting them, or actually knowing how to instrument them was extremely hard. You had to specify a schema somewhere and hope the entire delivering of machines and setting up topics and doing everything would work flawlessly. And then ultimately, maybe a few days later, you will actually see some data coming through. And that process was painful. So then we started thinking on how to make it easier and how to make it easier both to collect and to provide the right data. And that's when we started building SDKs that will live on the client, where basically content producers were able to specify an event in their native language and provide an object that had all the properties set in the right way on the clients. And we provide a very simple way for people to define the events, define the schema, tell them what information they should contain, so that everyone was able to see them, everyone knew what to expect. And at runtime, developers could try it out, make sure that if there were some problems, they could debug them early on and facilitate the entire process. And I think we went from an average of 3 days for someone to think of what they wanted to log to actually having the data logged to few hours. So that was a massive improvement in terms of making the entire event delivery more approachable to user, and in turn solving a lot of problems. Like we had problems with ownership. No one really wanted to own the specification of an event. The thing that I keep referring to is we had an event that was called client event. That was basically like an event from the client. And since most client developers had a hard time figuring out how to add new events, they saw that there was this event called client event, which just had a string inside, like a JSON string. And then everyone would just add the information to it. It's like, I just put this string called the client event. And then, but what it turned out, I think 1/3 of the entire volume was only client event, which means that everyone that wants to read the data has to filter out the entire blob of data just to get those few events that are relevant to him. So trying to solve that problem, I think it was the main effort back then.
So at this point, I started spending a little bit of time with some of this too, as I think we had like a cross-company effort to significantly improve the quality of our data and really define what good data was and what of our old data was good and how to make the things that weren't be good. So there's a lot of work to be done there. But I think you were always one of the, if not the person that we went to for these sorts of things. Like, how do we define good data? So I've always loved to hear you talk about that and tell some of the stories of like this client event thing, but even how we spread that across the company, how we made as much of the things as we could into good data.
Yeah, data quality has been top of my mind for a very long time. And how to solve it is not always clear. When I joined, if you wanted to run a pipeline or look at some data or store some data or do anything, you only had one user. So you had to log in into the Hadoop cluster as Spotify Data Analytics, I think it was called, and run your pipeline manually, which means that no one knew who was running a pipeline, who was looking at the data, who was generating data sets, how long they will be around, and what kind of quality you will expect from them. And the same holds true for events. So a lot of effort was in giving more transparency on who's responsible for an event. Would you expect the quality to be there and at which level of the stack they're in? So it could be like super important, super critical for the company, we can't have in loss, or it could be an experimental data set that no one really cares about. They just want to run an experiment for a week and then ditch it. So a lot of the focus was on making it as simple as possible for people to decide what they want to store, what they want to log, what they want to know about the clients, and making that as transparent as possible to the rest of the company so that they will know where the data was coming from. So huge effort was in ownership, and more specifically, not only ownership of the entire event, but also ownership of the data that it contains. Because I think that was another big one. Like, we used to deliver these events, and then there was a bunch of additional information added to it. And no one really knew how relevant that information was to the actual event. And the big problem comes to how do you provide valuable data in an event, yet provide all this additional information that is needed for people to make sense of it. I should probably bring in an example just to make things a bit clearer, but it's...
I literally just wrote down, when he's done, ask him for an example.
Yeah, exactly. No, I'm thinking because it's like those things stay in the air, but it's... Say that you're developing a feature and you want to know if your button was pressed. That's our like very typical thing. And it's like, okay, you get an event every time your button is pressed. And then that provides you some value, like you know if the button was pressed or not. But if it will provide you a lot more value if you will know what type of device was this pressed on. Was a song being played? How did you get to the page? What did you do before pressing that button? And a bunch of was like, who was the user that pressed this button? As in which country are you? So a bunch of information that lives around your event that gives you a lot more value. And the typical problem that we had before is like those servers that we are gathering data from were collecting all this information. There were basically big multiplexers where people would access to, and they will keep state of everything that was going on. But if you move that logic to the client, the specific engineer that is building that button that wants to know if it's been pressed or not doesn't necessarily want to own the logic to determine what's my IP address or I don't know, it's like what songs is currently being played, or is it a podcast or something else. So a big problem has always been, how do we make sure that the events have really high quality, which means that every field has the best possible quality, which means it's only populated by people that know or own that information. And yet we provide a very easy way for people to link that information with other things that are happening in the meantime on the clients. That's always been the challenge. And it's still an ongoing challenge for some aspects. Like we have solved the problem of static information, which is something like, what user is it? Is it free and premium? Are you playing on an Android? What's your IP address? Or semi-static information, say. But for dynamic information, we have kind of solved it in the sense of we provide an easy way of, we added some hashes, some unique identifiers for people to link events coming from the same device. But for other information, we are currently working on a solution for that. It's like, how do you append dynamic information? And dynamic information could be, was the phone in landscape or portrait mode? Or it's like, was it playing in foreground or background? And that's what we're currently working on. It's like, how do you append dynamic information to an event without having to make very complicated joins afterwards to get it out?
It sounds like a lot of the time when you were talking about quality, there were a bunch of things that were just metadata platformy things, like what is the device? I don't know what version of iPhone or I don't know, Samsung Galaxy or whatever this device is kind of stuff. That seems fairly straightforward. We just need a team that has expertise in that to do that. So every team isn't doing it. But then it seemed like you glossed over what it meant for the content of the data to be highest quality. You said every field being of the best possible quality, and you talked a lot about ownership and understanding. But do we have the definition of what it means for event-specific data to be of high quality? Or is that always up to the team and we just say, if you are closest to the problem, you define data quality?
We might go, there have been books written about quality in general and the terminology of quality.
Is that what your PhD is in?
No, not on quality. I'm never going to try it. That's an NP-complete problem. No, quality is way too much. The question is how trustworthy it is, how reliable it is. It's like that. What to me represents quality. If I look at the data set and I see that a field is not always present, that to me is of low quality. It's like if I cannot rely on the information being there. And it's okay if the information is imprecise, as long as I know about it in one way. Like if you try to always have the best of the best, you're never going to have anything. Everything starts bad and gets improved over time and as needed. So I've never been advocating for having the perfect event right away with all the information that you need. So you need to start somewhere. And then eventually it will get to a point where it's recognized as reliable information for everyone and of good enough quality for people to be able to rely on it. And we have several mechanisms at Spotify to be able to do that. It's like we have what we call the golden data sets, where people are actually responsible for ensuring that the fields there are of proper quality. We live off a few stacks down the line. And for us, we do what we can with the tools that we have, which means if you know who's responsible of producing that field and know how to reach out to them and know what guardrails they put on their data, like we have tests, we make sure that this is always produced and we make sure it's produced within this time or this kind of information. That's where I think enough quality meets the line for me. Personally.
Yep. And a bunch of this stuff we can do at the platform level. Someone just says this field must be present. It must be, I don't know, this kind of data. And they don't need to do more than that.
Exactly. So it's like we can help people do the right thing. It's always been about that. It's like you cannot impose a technology. You can only make it so good that people want to use it. And they want to use it in the right way, in the way that it's been intended to be used.
We talked a bunch about the history of the actual data collection systems, but I think some of this now we're talking about the evolution of the data itself. How much kind of similar history is there? Like that same, 2014 collection of PhDs team, maybe focused on distributed systems, but probably saw a lot of very interesting data quality things. And over the almost decade you've been here, have probably changed drastically, both in the systems that exist to enforce quality, but also just in what you see as quality in something like the event that says a button has been pressed.
I mean, there is a massive difference, but the major difference, I think, that originally we are moving bits. So it's like, it was not about the actual quality of the data. It was just trying to move some bits from one place to the other or get them off the servers as quick as possible. While now it's what we've been trying to do for a while, which is move up the stack. We're at the point where the entire data collection space thinks more about how can we provide system to ensure that people do the right thing and that is sustainable 6 months from now or a year from now. And I think really that moving up the stack is the biggest difference that I've seen in this last 10 years. So this space is still big to explore, but it's always interesting to see how different companies solve the same problem.
Yep. So then tell me a little bit about that. It sounds like we built just about all of this ourselves. And I want to say, it seems like this isn't a Spotify unique problem. So why is this something we've built a lot of ourselves? And what else have you seen in the world?
I mean, I don't know the insights of other systems, but I know that the ones that I've talked to usually have a way more imprecise way of logging things or saving things, a lot more custom. I think what we have been trying to do at Spotify is provide a solution for the company where they don't need to know how it works. It just works. And the interaction that they need to have with the system is simple enough. They don't try to find a way around it. For example, the interesting aspect now is that nowadays we have way more traffic going through our event delivery system coming from backends instead of coming from clients. And that's a huge success from my end. Even though no one talks about it and we don't put a lot of attention on it, thinking that someone builds a backend system that where delivery is not a problem, you don't have these challenges that you have on clients, like you have offline behavior that you want to be able to track. It's like it's a server within the same data center where you can just send the information wherever you want. They are still using the delivery system, means that you make it easier than a server-to-server communication or another way of saving the data. Like you make it more convenient for even for backend systems to use an event delivery instead of relying on another way of communication, which would be more native in one way. And why did we build it ourselves? Simply, we have a tendency of building things ourselves, but I think now we have done a couple of investigations. I wasn't present in those, but what I heard about is like no one operates at our scale and with our particular needs. At the moment, I think we are at 1.7 petabyte of data per day, trillion of events being delivered. I think at peak, we are around 50 million events per second. So it's an amount of load where there is no off-the-shelf solution for it. Plus, there is all of our caveats of compressing data, formatting it, and ETL job. We provide the data both on long-term storage, on GCS, we provide it on BigQuery, we provide it in a streaming fashion, so if people that want to consume it in near real time, they're able to rebuild streaming pipelines on top of it. And I think that there isn't a one solution fit them all.
So then what kind of stuff are you working on now? What's next that we're evolving in this space?
One that we briefly touched upon is trying to collect dynamic information from the clients. We have an easy way for people to link an event with other events that happen on the client. This is like, I have a list of streams that happen on the client and I have a list of actions that correspond to having pressed that button on the client. And you want to know which stream was playing when I pressed that button. You can join and have that information, but it's always going to be imprecise because you have, no matter how far up the stack you go, you can never be 100% sure that was the exact stream that was playing when you press the button. We have a multi-threaded applications, right? So it's like everything happens at the same time. It's impossible to be synchronous in event generating. And that's one of the hard problems that we're trying to solve now. It's like, how do we link events happening on the client and put them in the right order to be able to derive better understanding of what was happening. And we don't have a solution yet. We are close to one, but that's one of the interesting thing. And the other interesting thing that I'm personally working on is on trying to make the entire infrastructure agnostic to a specific location, like maybe in different clouds, but the idea of not being bundled to one specific implementation, that's what I'm personally currently working on. But there is a lot more going on in the space.
Yeah, so that sounds like there's a lot of complexity managed within the platform that is meant to make things just work for our engineers. But you mentioned different places where the data ends up, whether it's GCS or BigQuery or different ways that we join things across different events. How does that all get kind of brought to developers? Is that like another thing in Backstage where they see it next to all their other stuff? Or is there some completely separate system? Like, how do engineers find this stuff?
Mainly through Backstage, actually. So Backstage became this place where you find all the information about what's going on. And part of what you mentioned is actually the key point of it. We try to make it as simple as possible for people. If you have a feature team developing a particular feature, you don't want to have 4 data engineers there just to be able to understand and instrument everything. For example, if you have a data scientist there, we want the data scientist to go to the developers. It would be nice to be able to track this. And the developer doing it in their own native language, like building an object they pass along to us without having to know anything else with the information that is needed. And then automatically, everything appears in Backstage and you have your event with all your schemas and properties and all the checks in place, and the data scientist can go and do his job and can decide if they want to consume the data in a streaming fashion or have it on applying some Shio pipelines on the batching data or interact with it on BigQuery. So it's mostly Backstage as the backbone that serves metadata information about what's going on.
So a lot of whether it's the collection and kind of the early pieces in the definition or the kind of the other side where you're trying to do something interesting with the data and thus you need it already collected and joined and all of that, both of those kind of journeys start with someone finding things in Backstage. And that's where a lot of your tools are.
Yes, well, it used to be a different model. I remember back in the day when Backstage was mostly about services, and then we started adding just some monitoring tooling. And then we realized how powerful it was because everyone was used, especially in the backend world, they were used to that interface. And then we started to integrate fully all of our data world. So also lives within Backstage. So all the data endpoint or the pipelines that you're running, everything lives in one place.
That's really cool. Thank you so much for joining me. This has been a lot of fun.
Thank you. Nice to be here.
Outside of all of this data stuff, what other things do you nerd out about?
I like doing things with my hands. I spend too much time on computers, so it's like try to get away with it. And it used to be restoring engines, motorcycle engines from the 60s and 70s. Recently it's been restoring sailing boats from the ground up. I'm a bit afraid what's gonna be next. I have way too many hobbies that for the time that I have available.
That sounds great. I also love how drastically different some of these things may be, from sailboats to vintage motorcycle engines, but they all get you away from your desk and largely outside, so I'll support that.
Yeah, I used to contribute to open source operating system, and then I realized, no, I need to do something else. Yes. I need to get out of here.
Thanks for listening, and don't forget to hit that follow button so you don't miss an episode. If you have any questions or feedback, email us at nerdout@spotify.com. Nerd Out at Spotify is produced by Spotify's Ted Vergakis and by Seaplane Armada, who also wrote our trustworthy theme song. I'm Dave Zolotuski. Thanks for nerding out with us.